Welcome to the showcase of my 8-bit computer that I built in the Logic Simulator. As you can see, it can even run Snake, at least almost. The Apple part is missing because towards the end I unfortunately ran out of instruction memory. But other than that, it is pretty much completely working. Even if you run, for example, into the wall, you correctly die. So let's take a closer look. This is what it looks in the inside when it's running. Um, you can see the general layout of it. And yeah, maybe some more general information. It is an 8-bit CPU with 8 registers, where one of the registers is a dedicated zero register. You can see that in my register block, there are all the registers, all the 7 registers, with the dedicated zero that isn't even an actual register. Then I have 512 byte instruction memory, basically just one of those ROM blocks, which since each instruction is 16-bit, that means in total exactly 256 instructions, which is unfortunately exactly the limit that I hit now already. It got 256 bytes of random access RAM, and it roughly runs at 120 hertz. Well, at the moment, when I'm recording, not really, but usually it can run at 120 hertz. Yeah, then it uses a custom 16-bit instruction set that I designed. It has some basic instructions like add, addition, subtraction, some logical stuff, some commands for some immediate instructions, some instructions to access the RAM, some other helper instructions, and some branch instructions. ALU itself actually only has 5 different modes. It can either do addition, subtraction, XOR, OR, and AND. You can also see that in here. This is my ALU. It has an addition block. With this XOR here, I can switch it to subtraction, and it can XOR, OR, and add. I also have some pseudo commands, which aren't actual commands in the instruction set, but I can directly translate them to one of the actual commands. This also isn't a full list. Here you can see a full list directly from my compiler. So these are all the commands that my compiler supports, because I actually wrote my own compiler for this whole project. In the beginning, I thought this should be an easy task, but in the end, that turned into an 800 or almost 800 line long Java project. But yeah, it's a fully functional compiler for my own assembly language, which I then used to, for example, write my Snake program in assembly, which in the end also turned out to be a big project. The whole file is like 450 lines long. And then if I compile it, for example, with my compiler, I just call my compiler with the file, then I run it and it says the program was successfully compiled and saved in my output file. And if we look into the output file, this is what it then looks like. And this is what I can just copy into the ROM block. And as you can see, the output file is completely full. I only have 2 free bytes in the end left, or 2 free instructions, because unfortunately I just ran out of room for instructions in the end because the Snake program turned out to be so complicated. But yeah, it mostly works now if I correctly reset it. And maybe for the RAM, if you check it out, you can see I mean, it obviously has the RAM, and then for the I actually did memory mapped I/O. That means I assigned certain addresses of the RAM to the I/O stuff. So, for example, if I actually have a list as well. Here you can see it, for example, the from hex 00 to hex CF is my standard random access memory. And then, for example, from hex E0 to hex FF, I have the pixel display. So, for example, if I want to write something to the pixel display, I just have to store those data, that data to these addresses. And yeah, that's basically my whole CPU. Thanks for watching.